Okay, that brings us to our next speaker, Dominika Varga. And the title of the talk is The Neural Correlates of Different Sources of Surprise Evidence from Two Naturalistic fMRI Studies.
Yes, thank you. Hi everyone, I'm Dominika. I'm a research fellow in psychology at Sussex in Chris Bird's lab. And I'm very excited to tell you about one of our studies today where we tested the neural correlates of detecting different sources of surprises in lifelike situations. So in everyday life, we are surprised when an event contradicts our prior expectations of what is likely to happen in a situation. But depending on the situation, our source of expectations can come from different memory systems. So, for example, we can rely on our general knowledge of what we know usually happens in similar situations, or our episodic memory of what we remember happened in a specific past experience. So, for example, if you imagine that you enter a new restaurant that you've never been to before, you can still rely on your general knowledge to expect to be seated and given menus, to have your order taken, and eventually to receive your meal. But in this restaurant, you get your meal in a shoe. So this might be surprising based on your general knowledge of usually getting your meal on a plate. However, if you were to visit this same restaurant the second time, the shoe might not be surprising anymore. But if you saw that the menu has completely changed, this might be surprising based on your episodic memory of the previous visit. So we can be surprised for different reasons. However, it is unclear whether detecting these different sources of surprises relies on the same or distinct neural substrates. So in the experiment I will present to you today, we specifically focused on the hippocampus's role in detecting surprising events because there is a long-standing idea proposed by many models that there is a common predictive process in the hippocampus that can account for both episodic and general knowledge-based surprise detection. So, for example, according to the SLIMM model, whenever there is an event that contradicts our prior expectations, hippocampal should increase in response to that. So, from my previous example, it would be involved in detecting both the new menu as well as the shoe for plate. However, interestingly, all prior studies that this idea relies on rest on just episodic memory-based surprise. So, for example, in these studies, people learned a sequence of items, and then later, these remembered predictions were violated by showing the items in a surprising order. So, these types of studies can only provide evidence for episodic memory-based surprise, and there is actually a lack of evidence if the hippocampus would be involved in also more general knowledge-based surprise. So, to test the hypothesis that the hippocampus is involved in detecting any source of surprise, we created a naturalistic paradigm across two pre-registered fMRI experiments, where, first of all, we manipulated how contextually surprising events were in video clips of everyday situations. And we also manipulated the source of expectations that people could rely on while watching these clips in the scanner. So, inside the scanner, in both experiments, everybody watched half of the clips where all the actions were context congruent, and half of the clips where there was one action that was incongruent with the context. So, as an example, participants either watch the congruent or incongruent version of this clip, where everything is identical, except that in the congruent version, the person put clothes into the washing machine, whereas in the incongruent, the person put flowers in the washing machine. So everybody watched these clips, and the difference between the experiments was how familiar people were with these specific clips before entering the scanner. So, in the first experiment, people were not familiarized with these clips. So for them, if they saw the flowers put into the washing machine, this was only surprising to them based on their general knowledge of how people usually do the laundry. Whereas in experiment 2, people watched all the congruent version of the clips. So for them, watching the person put flowers in the washing machine was also surprising based on their episodic memory of previously seeing the person put the clothes into the washing machine. So to test the hippocampal response to these different sources of surprises, we compared its average level of activity between the congruent and incongruent actions in each experiment. And what we found is that hippocampal activity was not modulated by how surprising events were when they only violated general knowledge-based expectations. However, when the events also violated episodic memory-based expectations, now the hippocampus showed increased response to these incongruent events. So these results provide evidence challenging models that propose an overarching role for the hippocampus in detecting any source of surprise. And we actually suggest that it is only involved if events violate specific memories. But of course, in this second experiment, there is kind of a double source of violation. So it could be that that's the only reason for the increased hippocampal response. So to exclude this possibility, I'm very happy to show you actually some preliminary findings from a third experiment we ran, where actually this time we showed people the incongruent version of the clips before scanning. So now the congruent action, so the person putting the clothes into the washing machine, were the surprising events inside the scanner. And that only violated episodic memory-based expectations. And now we show that the hippocampus increases its response to the congruent events instead. So this supports our idea that the hippocampus has a specialized role in surprise detection, and it really only cares about prediction violation of specific memories, and it does not have an overarching role in more general surprise detection. And finally, I would just like to show you some exploratory findings in some cortical networks that are important for event comprehension and where we would expect to see surprise-related response. So, first of all, the semantic control network has been shown to be involved whenever an event violates long-term semantic knowledge. So we would expect that in both experiments, the surprising events would engage this network. And indeed, this is what we find. Then the multiple demand network has been shown to be more involved when more attentional resources are required to interpret surprising situations. So again, we would expect that our surprising events in both experiments engage this network. And this is exactly what we found. And then lastly, we also looked at the default mode network, as this network has a more specialized role in retrieving memories of past experiences and using this information in order to predict upcoming events. And in this network, we actually showed that only when events violated those episodic memory-based expectations did this network increase its activity overall. So from these network results, we can see that in both experiments, there was some surprise-related response across the cortex, and that more general knowledge-based surprise is probably processed independently of the hippocampus, partly in these cognitive control networks. So just to summarize the key points from my talk, we showed that the hippocampus has a specific role in detecting surprising events, and this is when expectations are supported by episodic memories. So with these results, we challenged models of hippocampal function that propose a more overarching role in surprise detection. Then we also showed that surprise on more general expectations may be processed independently from the hippocampus, for example, in cognitive control networks. And then lastly, the main implication of these findings is that models of surprise or prediction error detection mechanisms should really take into consideration the source of prior expectations and should not take all kinds of surprising events as the same. So thank you so much for your attention. Thank you for the opportunity to give this talk, and thank you to everyone who was involved in this project.
Thank you. We have one question from the audience. Do you think that semantic and episodic memory are two distinct systems or more like a continuum?
Oh, okay. Yeah, that is a really interesting question that actually I think I never considered so deeply. So I think they are very, very related, obviously, because whenever you try to recall even a very specific past episode, you still rely on your semantic knowledge to kind of construct this experience. So definitely related. Maybe, yeah, from this kind of, if I had to choose from both, just the two options, maybe I would say it's a continuum from something very, very specific to something more general and abstract form of memory. Maybe that's what I would say, but yeah, I don't know.
Thank you. Any other questions?
There is someone in the very back. Yes. So actually, yeah, in that, so the question was whether if somebody was it was already in their kind of general knowledge that it's normal to put flowers into the washing machine, whether their brains would react differently to this type of strange event. So yes, from the third experiment, we showed that if people have already seen that event in the past, the hippocampus doesn't respond to it as much as if you have never seen that before. So it's really, I think, about whether that specific instance has happened before or not, and whether you can kind of make a clear connection between those two events. So yes.
Okay, thanks very much, Dominika.
Thank you.